Now, as we have learned about the effects of forces, we have learned about the net force also, that the resultant force, that one force is applying from here, one force is applying from here, what will be the resultant force on the object. Now, moving forward, let us see the types of forces. What kind of forces we are having? Okay, there are mainly two types of forces, that is, one is contact force and the another one is non-contact force. Have you seen that this pen is held by me, and if I am not going to hold this pen like this, will it be able to hear only? No, it will seriously drop down. Okay, it will going towards the downward direction, definitely. So, why it is going to downward direction automatically? Why it is not floating here only? Because there is some kind of force acting on it right now. Okay, and the previous examples like pulling a cart, riding a bicycle, pushing a car, all these kinds of forces are required to have the contact with the object. Am I right? Yes, definitely. Without touching the object, you cannot even move a feather without, with the blow. If you want to move a feather, let's suppose, you have to blow it with your mouth. But here also you are providing some force. That is force you are providing with the air of your mouth. Right now, so we can say that there are two kinds of force. One we have to touch with it, and the another one we don't have to touch anything. Okay, now, so first thing is muscular force. Now tell me, students, what kind of force is a muscular force? Is it a contact force or a non-contact force? Yes, definitely it is a type of contact force. Why we are saying this? Because we have to provide the force with our muscles. Right now, if you are not a muscular man, you are not going to push the box without the help of your friend. Right? So, muscles and muscular force we are applying with our body or any kind of organism which is providing the force because of its body muscles, that are known as muscular force. And there are various examples of muscular force, like even your heart is beating and your heart is made up of muscles and it is pumping blood all through your body. And if the heart stops working, you know what going to happen. Right? So, yes, it is muscular force which is the reason why we are alive. And see, this is the previous example. We have learned about it, that the muscular force is able us to move the cycle from one point to another point and the cart from one point to another point. This is all muscular force, and in day-to-day life I am dead sure that you can see various examples around you where you have to apply the muscular force. Even opening the door requires muscular force. Even closing the door required muscular force. Even writing with the pencil, even writing with a pen, all these things required muscular force, right? Now, second one is frictional force. So, what is frictional force? Dear all, this is very new topic for you. Yes, and you have to remember this, you have to learn this topic thoroughly, okay? See, what is the concept behind it? Okay, frictional force is actually the contact force, the contact of two objects. So, it comes under the contact force. This is one thing. But the another thing, why we are calling it frictional force. Frictional means the rubbing of two objects. The force which is applied by the two objects after when we are rubbing it. See the example, the truck with the heavy tires. It's riding over the road, right? It's drove over the road. Now, what is going to happen? The tire, the surface of the tire is in contact with the surface of road, right? So, we can say that molecules of the tires. Here, let me zoom the molecules of the tires, and here these are the atoms or molecules of the road also. So, these will be in contact. There will be a contact layer between these, and definitely eventually after some time there is having a adhesive force between these molecules. Adhesive means connection, adding. Okay, like Fevicol. Okay, Fevicol is adding two objects adhesive force. Fine. So there is a generation of this adhesive force between two layers of any surfaces when they are in contact. After a while, if you want to move that object from one place to another place, then you have to provide external force. Right? So see, let me tell you, this is a box. This is one example again. Let me tell you, this is a box, and if I want to move it from in this direction, so there will be a frictional force between the layers of these two surfaces, right? But these two surfaces don't want to move the box from here to here. Fine. So the frictional force want to move it in here. That means stay here only. Don't move from here to here. So this is applying in the opposite direction of this force. This force is moving in this direction. So this force, frictional force, will always oppose the moving of the object. It prevents the thing from moving. It always opposes the motion of the object. Okay? Now, moving forward, you can see the gravitational force, and I know you have heard about it a lot time, and even before a while I am telling you the example that if I going to drop this pen from here, it is suddenly moving towards the down direction. Why it is not floating here, or why it is not sticking to the screen only? Why? Because gravitational force, and it is provided by our planet Earth. Yes, our lovely planet Earth. It is all provided by this thing, and it is pulling everything on the Earth towards itself. Why is it so? What is the factor it is going to perform? Why it happens that gravitational force is acting on each object? It's because of mass. Okay, students. Now, this factor is very, very important, because any object in this whole universe is having a mass. It's actually providing the gravitational field around itself. And more the mass here, more the gravity here. So you know already that our Earth planet is here, and it is the third planet of our solar system. And after this, we are having one more planet which is very, very large. What is the name of the largest planet of our solar system? Yes, that is Jupiter. Right, students? So now let me tell you which out of these two, Earth or Jupiter, having more gravity. Because Jupiter is having more mass, so we can say it has more gravity. Whichever thing which is having more mass. So let me tell you, dear, we are also having mass. We are here as a human. This pen is also an object. It is also having a mass. Are these objects do us also have a gravitational force around us? Yes, definitely we are having a gravitational force around us also. As I have told you that gravitational force is because of mass we are going to provide, and more the mass is here, more the gravity is here. That is why in our solar system, all the planets are actually revolving around the sun. Why? Because sun has the largest mass in our solar system. So think yourself that is there any more mass compared to our sun also in our solar system, or around our solar system, or in the universe, which is the largest thing that has the largest mass? Yes, black holes. Black holes are having the largest mass in this universe. That is why they are having the largest gravity. And that gravity is actually exerting the force towards each and every solar system around it and pulling it towards itself. There are some more examples of force here. Let me tell you, if I am keeping two cars and I am taking them up towards the space. Okay, मैंने इसको अर्थ से ही बाहर ले गई, ठीक है? Now, tell me dear, these two cars are going to attract themselves or not? Yes, of course, they are going to attract themselves too, because they are also having a mass here. Yes, but now if I am going to put a earth in between these two cars, are they now going to pull towards itself? अब ये अपने आप एक दूसरे की तरफ आएंगे, or they are moving towards the earth. Just tell me, what is going to happen now? Obviously, they will move towards the earth because there is the 30 billion times more force which is provided by the earth planet compared to the force that is provided by these two cars itself. Now students, after gravitational part, here is coming the most favorite part of all students. Yes, that is the magnet force. Yes, in our childhood, we have seen lots of magnets that are selling at these grocery stores also, and I used to buy a lot magnets and I used to play a lots of magnets because magnets are too much fun. So these are also a kind of force, dear, because magnets are providing the force towards itself or on each other or any certain metals. Yes, they are exerting force on any metal, that is like iron, nickel, cobalt, and these kinds of forces are known as magnetic force. Okay, and you might have seen the scraper, that is scraper bean. Yes, what is the use of this scraper bean? In a lots of garbage, in the heaps of garbage, what this crane is going to do, there is a huge magnet which is at this this magnet is like this here, and here is a heap of the garbage. So if we want to collect the iron stuff from here only, so now how we will collect the iron stuff from here? So this magnet is going to take the help of magnetic force, and all iron will again with the help of magnetic force will going to stick on the disc. So now students, we have learned that a magnet can act from a distance because it is surrounded by an invisible field of magnetic force. Yes, if we are having a magnets like this, these magnets will have certain invisible magnetic fields like this. Okay, and these magnetic fields are actually responsible for the force, that is magnetic force. Okay, so here students, it is written N and S. What is this actually? This is actually a north pole and a south pole. Okay, so in every object, in every magnet, we can see that there are two types of poles, that is north pole and the south pole. And if we want to keep them aside, okay, like this, so whenever a north pole is at the side of the south pole, like in the diagram you can see north pole is just beside the south pole, so they are going to attract each other. Okay, and if these two are in opposite direction like this, north pole and north pole are aside and south pole are in between. So whenever two like poles are facing each other, so they have to repel each other. Okay, so now you have to see here that whenever two opposite poles are facing towards each other, they are actually attracting each other. And the similar like poles, if they are facing each other, they are actually separating from each other. So with your toys, magnetic toys, you can see there also sometimes it is attracting each other and sometimes they are repelling each other. So what is the phenomena behind it? The phenomena is exactly this. If the south pole and south pole are facing towards each other, they are repelling each other. And if the north pole and the north pole again facing each other, same, right? So they are repelling each other. But one is south and one is north, attracting. One is north, one is south, attracting again. Okay, so opposite one attract and different one, same, similar, alike, will repel. Yes, after magnet, there is very important topic that you should know, students, that is electrostatic force. And why is it important? You are going to see. This name is suggesting you that this is related to your electricity, and without electricity, nothing is going to happen in these days, right? See, have you seen this thing before? That a pieces of paper is going to attract a comb? Yes. Why it is happen? Is the magnet fit in this comb or in the pieces of paper? Nowhere. Nowhere is magnet is here. Then why it is attracting towards the comb? Okay, there is a very big reason here, that is electrostatic force. And one more example, you have seen that your hairs is going to attract towards some kind of insulated object, that is even a balloon or a rubber or a plastic or anything. So why it is attracting towards these things? Even they are not conductors, they are insulators. Why is it going to happen? So the main reason behind is it electrostatic force. What is electrostatic force exactly? It is the force that is exerted by the charged particle, and that charged particle, the force which is attracted by them, is known as electrostatic force. There are mainly two types of charged particles. One is positive charged particle and one is negative charged particle. So positive and negative, both these charged particles, where are they present? They are present in the atom. Have you heard about this name before? Definitely. Atoms are the basic units of any object that is around in this universe or in this planet or here in your room also. Even in this marker. Okay. So anything you are seeing here is made up of atoms only, and in atom only there are two kinds of charged particle. One is positive and another one is negative charged particle. So positive charged particle and negative charged particle, in the same manner we have seen the North Pole and the South Pole in magnet case. Whenever the South Pole and the North Pole are facing towards each other, they actually attracting each other. In the same manner, when we are having the opposite charged particle, they are going to attract each other. And when we are having the same kind of charged particle beside themselves, they will definitely repel each other. Yes, negative will repel each other and positive will repel each other.